In the last video, we went over how a C++ program might be written in MIPS Assembly. So now we're going to be writing a very similar program in MIPS, but the last one we used static variables. This time we're going to be using local variables. So if you notice, the code looks a bit different and maybe a bit more like the code we're used to writing in C++. We define all of our variables here inside the main function, and then we have this if and else statement which involves all of the different variables. So we're going to go through this one a little bit faster, and we're assuming that you looked at the previous video and have a pretty good idea of what's going on. So we're just going to go over the differences. So first, notice we have our data segment. Now I didn't even have to really write this, but I decided I want to write this just to show now we don't have any data segment, which means we have no static variables. So all the variables are going to be created during runtime, so they're going to be local variables to this to the main function. So let's just go through the text and see what's going on. So what we're going to do here is this instruction is add I, which is add immediate. So I'm essentially taking these values here. So these are actually different, but I might as well just keep them. I mean, this doesn't matter. Whatever I put here and here, it doesn't matter. It's just arbitrarily chosen numbers. But I'm adding this number, this register 0. So if you notice in the register column, we've got the name 0, and it's a constant 0. So that means it's going to be the number 0 no matter what. So we're just adding the number 0 to this register, which is number 0, and we're putting it here in S0. So we're going to add 1 to 0 and put 1 there, 2 to 0, put 2 there, 3 to 0, put 3 there, 4 to 0, put 4 there. So now each one of these registers is going to have the value 0, 1, 2, 3, 4. So then what I'm going to do here, so this is going to be a little bit different. In the last program we never used the stack. This time we are going to be using the stack, and the stack is where we're going to be storing our variables, our local variables. So what I'm doing right here is subtracting 16 from the stack pointer. So this is a little bit confusing, especially if you've never heard of the stack. But you have to imagine that the stack has a bottom and a top, and the bottom is going to have the biggest memory address. So think of it like a pyramid, like the biggest stuff is on the bottom and then it gets smaller as it goes up. So say the biggest memory address, say the memory address is 1,000, then going up we're going to have, if we subtract 16, we're going to have 1,000 minus 16, which is 984. So it's going to be 984 on the top. So that's just an example of why we're subtracting to get to the top of the stack. And the 16 is going to allow us for 5 local variables to be on the stack. So we would have, so let me just go over what we're doing with this 16. So we're taking this 0, 0, or we could have just written 0, but I just wrote 0, 0, is going to be the offset. So if you think about it, if the stack pointer is 16 bytes back, the first index is going to be 0, and then moving forward 4 is going to be 4 bytes forward, 8 bytes forward is going to be the next one, 12 bytes forward is going to be the next one, and 16 bytes forward is going to be the last one. So this might be a little bit confusing, but again, we're going to go over it. But essentially, what we're doing is here we have these values S0 through S4, which we already gave these values 0 through 4, right? So we know that these registers are going to be storing the values 0 through 4, and we're just going to be putting those on the stack. So you could think of the stack sort of like an array. So here's the first index, here's the second index, here's the third index, here's the fourth index, here's the fifth index, and we're putting the numbers 0, 1, 2, 3, 4 in those indices in the stack. Once we run this program, which we're going to do, it might be a little bit more clear exactly what we're doing. So the next step is, now we have everything in the stack, we're going to take what we have in the stack and we're going to put it into a temporary register. So here I take these numbers, right? So remember, this is like this 12 would represent the number 3 because we stored the number 3 in 12, and we're going to put it into this temporary register. So then, similar to the last program, we're testing to see if T3 and T4 are equal. So these are going to be I and J. And just to be clear, remember we said we use S for things that we want to keep for longer, and then T is for temporary. Again, it doesn't make a huge difference, especially in this program, but it seemed like a good choice for this. Now, another thing that you might be noticing is that we move things from, we took a number, put it into a register, and then we put it on a stack, and then we put it back into a register. Now, there might be a simpler way to do this, but I'm not sure because I couldn't figure out a way to store an immediate on the stack. If anyone knows how to do that, that would be a better thing, in my opinion, because it seems a little bit redundant. But here I just want to use the stack, so this is what we're doing to just show how it sort of works using the stack. So again, we branch not equal if T3 and T4, so if I and J are not the same, we're going to go to else, which is right here. And so these steps are essentially the same as they were in the previous video. And then right here what I do is we take whatever's in T0, which is going to be the value F, and we're going to put it back onto the stack. So we're going to notice now our stack is going to change. And just because we're using these numbers, so G is 1, H is 2, so if they're the same, then this number 0 should have the value 3 at the end, and if they're different, which they are, it's going to be -1 because we're going to take 1 minus 2, and that's going to be -1. And that's what's going to be in this part of the stack at the end of the program. So we're going to run this program, assemble, and everything works. And again, we're going to have these different things. So the data segment now, we're not going to use the data segment, right? Because we didn't make any local variables or static variables. So I'm going to go to the stack pointer. And so this right here, you see the address has changed. So this is where our stack is. And if we notice right here, this is the stack pointer. It is at 0x7FFFEFFC. And if we notice right here, this is 0FFFEFE0. So FE0 plus 1C, if we take E and add 1, we're going to get F. If we take 0 and we add C, we're going to get C. So that's going to be this. That's going to be here. So this right here is the top of the stack. So we're going to remember that because when we shift the stack over, it's going to be more obvious what's going on. So first, right here, you see these instructions is we're just changing the values of these registers, right? So S0, S1, S2, S3, S4. So we'll just notice right here in this column, in the S section, we're going to be putting these numbers. So see that 0 goes there, 1 goes there, 2 goes there, 3 goes there, 4 goes there. Okay, so now our next step is we're going to subtract 16 from the stack pointer. So I push this button, and now you see it's FEFEC, right? So that is going to be E plus 12, right? So that's this number plus C. So this is going to be our top of the stack. So what we're going to do now is we're going to take what's at S0, which is 0, and we're going to put it there. So this is going to be the same, right? Then the next step, we're going to be taking what's at S1 and putting it 4 from here. So this is 0 from here. This one's going to be 4 from here. And remember, what's at S1 is the number 1. So this one right here is going to have the number 1. And continuing, we're going to get the number 2 the next one, 3 the next one, and then 4 the last one, right? So that's what we did. We moved the stack over here, and then so we could index it like this way. So continuing down, we're going to take these values from the stack, and we're going to put them in the temporary register. So we're going to notice that these are going to get updated with the values from the stack. So that's going to have 0, 1, 2, 3, 4. Then we're going to do the same thing. We're going to compare the two values, and then we're going to go to else if it doesn't work. So we know that these are not the same, so we're going to go to else, and we're going to subtract 9 from 10. So remember 9, so T0 minus T1, so it's going to, or sorry, T1 minus T2. So it's going to be 1 minus 2 is going to go into T0, so that's going to be -1 or all F's if we know our hexadecimal, right? That goes to all F's. And then finally, what we're going to do is we're going to store what we have here in what we have in T0 into the address of the stack pointer, right? So we're going to run the next one, and then we see the F's go right here. So remember that this is where we had our letter F, right? F is equal to 0. So so that's what we did, right? We put because remember this code, right? We subtract G minus H is going to be F. So we took 1 and subtracted 2, and then we put that there, and then we put that back in the stack. So that's why this is in the stack. And that's it for this program.